Good morning, everyone. All righty. Thank you, my daughter Juliana. Hope you guys are doing well. Say good morning to Harold. Hi, Harold. It looks like I'm all by myself. I don't want to be by myself. I got Harold with me. Anyways, I know it's Tuesday morning. I know everybody's probably tired. I am too. And hope you're doing well. And let's just talk about where our projects are going from here. I haven't seen too much from too many students in the 8th grade, and I hope you're working on your stuff. I've gotten a lot more projects from 6th and 7th graders who are doing something different. And understand one of the things we talked about with Lyft, when you are talking about your project, we did talk about the amount of surface area that's present and how this has a lot more surface area than this. This plane literally only has this little area and this little area. Well, we changed it. We didn't change the mass of this. It's the same, but we did change the surface area. Hey, Brianna, when we change the surface area, then we're creating more surface area for that to interact. Remember, if we don't have any fluid, we don't have any lift. And in this case, fluid is the air, okay? And something happened this weekend. I was out of state for the weekend, and we were in a little bit of a valley, in a holler, as they call them down there, with mountains on both sides. And so it was sunny, and then the weather all of a sudden started to change. And it was cool because what I saw happen really was a little bit of Newton's third law. And because you look up at the sky and you see clouds moving in kind of rapidly. So there was a storm front moving in. And as it moved over us, remember we have mountains on both sides of us. So what actually happened was the wind came from the opposite direction. And it caught my attention because I happened to be looking up thinking, oh man, this storm is moving this way. And then all of a sudden the wind started blowing pretty strongly in the opposite direction. And it made me realize that what actually was happening is that there was an action and a reaction, and that wind was coming in with force and hitting that mountain and turning around and literally bouncing back in the other direction where we were. And it was the last thing that I really expected. And then that little bell went off, and I was like, oh, this is cool, because this is kind of relates to what we're talking about. And it made me think about wind direction and how wind direction plays a role in what we're doing. Typically, winds will blow from one direction to the other. There are something called prevailing winds, and prevailing winds have to do with the spinning of the earth. And so where we live, the prevailing winds are actually out of the west-southwest, if I'm not mistaken, west-southwest. And so our storms come out of typically the west and move east. We don't very often, or literally almost never, have a storm that's coming from the east and heads west. Sometimes when we're behind a large pressure system, lower high pressure system, we have winds that can come out of the east, but that system itself is moving from west to east. And so it kind of made me think about the way airports are set up. And if anybody's ever flown out of Akron Canton Airport or Cleveland Airport, or if you've actually seen Akron Fulton, Akron Municipal Airport over by the that big black air dock, you'll notice something, and that is the direction of the runway. And the runway actually heads a little bit, it basically heads from northeast, got that right? Yeah, northeast to southwest. And why? Because that's where those prevailing winds are. And so when planes take off, they're going to take off into the wind, okay? Because the wind is coming at them, is going to provide additional lift to help them get up in the air quicker, okay? And so I wanted you guys to think about the importance of wind and what role the wind actually plays when you have a task when you're trying to accomplish lift. So planes will actually take off into the wind because they'll lift up quicker, and they'll land into the wind too, because it'll be a much quicker, much easier descent. And so even on if you're going down 77 towards Canton, you can see planes will come right in over the highway and land. They're landing into what is generally the wind direction out of the west-southwest. And so it's really cool to think about, how can this play a role in what I'm doing and whatever my project is. So when you do go outside trying to make these things work, think about where the wind is coming from, where the wind is blowing, and how that might play a role in how you're doing. If you're going to be throwing something and the wind's blowing, you're going to throw it into the wind, you're going to throw it with the wind, and so that's going to play a factor too in what kind of results you get in your project and how long it stays up in the air. Because lift is generated by that difference in velocity. Velocity meaning, let's use the layman's term of wind or air movement or speed. So if you increase the velocity, you can increase the lift. So if you had a plane, the faster the plane is going, the easier it can have lift. And so if a plane wants to fly at 10,000 feet, what does it do? It increases its velocity. It can adjust its wings a little bit, its flaps and things. But what does it do? It increases its velocity, which allows it to have more lift, which is going to get it higher up in the air. And so we have to think about that when we're talking about how long we want to keep this thing in the air. How is the velocity of the wind, which is a fluid around us, affecting it? And so it can affect it very positively, and it can also, depending if it's, sometimes winds will push down towards the earth. And so it also depends on what's going on, what time of day. Winds, the air will also rise. Hey, Kennedy. By the way, this is 8th grade. You're not going to get much out of this. We'll be on at noon for 6th grade. And so when you have air rising, is that going to play a little bit of a role in creating any lift for your airplane or whatever you happen to be using? And there's one more point I wanted to make. Remember, air is a fluid, air is a gas, and we're just talking about using air. We're not going to use any special gases in this. But remember Newton's third law. You're getting lift because wind is pushing on this and then turning directions and pushing down and pushing the airplane up. Okay, so it's about that opposite reaction, that action and reaction. If we're playing soccer or playing kickball and somebody brings a ball in, I kick it, that ball comes in, I kick the ball turns around and goes in the other direction. Equal and opposite reaction. There's also a reaction to my foot. You might not see it, but it probably is, it really is slowing my foot down. If my foot's coming through and hitting something and sending that off in the other direction, there's more mass in my foot than there is in that kickball, but it is doing something to my foot. It might change its trajectory slightly. It might slow it down. If you had two equal objects, you would see a more equal reaction, but typically we don't. So don't forget about Newton's third law that's playing a role in that. Trying to think what else I need to think about. Time of day. Why is time of day something to consider? Because we have to think about temperature. When we have sunlight, the sunlight warms the earth. The warmer the earth gets, the more you have air that's actually rising. Is that providing even a slight difference in your lift? It might. And so things like that to consider. And Mr. Fosnight just pointed out the amount of moisture that's in the air too. Typically we think of mornings being a little cooler. The air's typically a little more dense. Wait a second, air has mass, air has weight. Okay, so how is that going to play a role in it? Okay, and so it would be really cool to try the same experiment at different times and see if there's a difference based on basically what we're talking about is air pressure, air density and air pressure. Is the air, is it humid? Is it moist? Is it dry air? What is the difference in the amount of lift? Remember, air that has a lot of moisture in it it's more dense, it has more mass. Okay, so what is going to be required to achieve the same amount of lift in different air qualities? And so those kind of things are really important to think about, and we don't think about them in everyday stuff, but they will play a role. The other thing is too, if you got something that's made out of paper, be aware of like what the grass is like. If it's really wet, your paper parachute, which by the way, I've tried this, it works pretty good. And I think, but this would get ruined really quickly in wet grass because it's very thin paper. I talked a lot about surface area, and I picked this little cowboy because I thought he had an appropriate mass. That was based on not me reading anything, but based on my past experiences. And I think it kind of paid off, because if I had put something heavier on it, it would have just quickly fallen to the ground, right? It didn't matter the amount of surface area that I have here. And there's a lot of surface area on this parachute, enough, basically to cover this whole screen, right? And you can see this is probably about 18 inches. I even got a little tear in it. And it might even be more. I don't know if that's 16 by 24, but it worked real well because I think I had the right combination of mass to size to surface area. So those things you got to think about too. Sometimes people are getting things to fly, like if they're doing some sort of a plane, but it's flying erratically. Okay, so you need to think about, what can I change in a plane? If you actually look at what planes look like, typically they will have a real plane will typically have wings in the front. You have the fuselage, which is the body, and let's just say this is the fuselage of the plane. You have the nose and the tail, and you have your wings here, and they're swept back. Okay, and we all think, okay, that's easy enough, I can do that. But in the back, we also have a tail, and usually wings and kind of a fin in the back. And so how is that playing a role in controlling the plane? Hey, Malachi. And so that if you're doing a paper airplane or of some sort, then you need to consider, yeah, I'm getting good flight, but it's erratic. I'm getting good flight, but it's dive bombing, or it's turning or whatever. Then you need to think about, how do I add something to the tail to counterbalance that? Okay, because and think about where your center of gravity is. Do I need to do something like add a weight somewhere? Do I take like a nickel or a penny or a quarter, or maybe 2 cents? You got to put your 2 cents in, right? And add them somewhere onto that plane to balance things out. And so sometimes you might want to add some weight to the tail, if the tail is lifting up, or to the wings. And so you want to get things in balance if you can. And so that's important. But some people have flown planes and they're dive bombing, or they're going straight up in the air, and those things can be corrected by putting a proper tail on it. You guys can all Google an image of what a plane looks like. You can Google images of what a parachute looks like, and you guys can come up with any, and I've told you this before, you come up with any model you want. And so your goal, remember, is to take a quick short video. Now, some people are questioning whether this is going to work or not, whether they can do it. Well, if you have a phone, you can do this, because I've already had videos sent to me from a phone that were just sent to my email very, very easily, and it can be done as a Google Share or sent. Google Share might be the easiest thing. And so I've already watched some video segments from people's experiments, and cool stuff, really cool stuff. So don't be shy about doing that. And I am going to post what I'm going to call a recap sheet. It's just maybe a paragraph for you to review what you've done and what you think went well, what you think did not go well. And so I'll have that posted probably sometime this week, because I don't know if there's super urgency on it, but I wanted to post that. And then we're going to, if you haven't gotten this done, you can still work on this, but I'm probably going to start talking a little bit more about some other mechanical things with physics that we need to get into our conversation before the end of the year. It is 25 after. I'm going to cut out and give myself a chance to get ready for next class and make sure I'm out before Mr. Murray gets on. Hope you guys are doing well. If anybody has any questions, please ask now. I'll wait a little minute, play a little bumper music. Feel like a DJ playing some bumper music. And we have to have a word of the day. Word of the day, I think, is going to be groundhog. Groundhog is the word of the day. If you get on Google Classroom and send me the word, see you at 12, Kennedy. You send me the word of the day. Thank you for staying, hanging out with us. You'll be great in 8th grade because you got this. If you get on Google, you too. If you get on Google Classroom and send me one word, groundhog, I will give you a bonus point for doing that. Hashtag sleep time. Yeah, that was me last night. So, I'm a little tired this morning. So, you guys have a great one. Hopefully the sun will stay out a little bit today. It won't be long. It'll be nice warm weather. Take care.